Hi guys, hope everyone is doing good. So first of all, could you please tell me that you can hear me or not? Okay, okay, great. Uh, Now I'm going to start the session. So I'm also recording this session. So if anyone cannot participate this or anyone need to leave this session, you can leave. I'll post this recording on the Blackboard. Okay. Uh, I have planned to please let me share my screen. I'm trying to first do the chapter 1, 2, and 3. I already a little bit edit these notes which I already sent you. This is like a summary for chapter 1, 2, and 3. Then I would like to go through the review, mid-exam review, which I already sent you. Okay, let's start this one. Chapter 1. Uh, in this chapter, actually, it is full of theoretical stuff. So you just need to get a rough idea what is this, what is that, something like that. Okay, but there are like 7 8 questions directly based on chapter 1. Okay, because there are so many theoretical stuff you should know in the first place. Okay, okay. Actually, section or chapter 1 based on nature of statistics, it is some kind of basics of statistics. uh, I don't want you to remember what is the definition of statistics. Okay, so I'm not going to ask that, but keep a rough idea what is what is statistics. Okay, it is a science of organizing and summarizing both numerical and non-numerical information. Okay, okay. Definitions, these two definitions, population and sample, those are two major definitions in statistics. So please try to remember what is the population and sample. Okay, you may have questions based on population and sample. Population is the collection of individuals. Simply, it is the whole world what we are considering in our research or what we are considering in our survey. For an example, if I need to do a survey to check whether the undergraduate students in uh, entire United States. Okay, so I have to consider all the undergraduate students in all the universities in United States. Okay, so undergraduate students in all the universities goes to population. Okay, so population is the big one, and then sample mean a part of that population. Okay, a portion from that population. Simply Texas Tech University and all undergraduate students who is studying in who are studying in Texas Tech University, something like that. Okay, so I have simply used this figure here is population. You can take the sample. Sample consists of like few items from the population. Okay, sample is not equal to the size of the population. Okay, uh, actually I didn't mention here, but why do we need a sample instead of population? We need a sample because we are not able to perform our survey or our study based on population, because population is huge. We cannot perform something like using population. So it takes some time. It is time consuming. It takes some money. So to reduce all the disadvantages, we try to reduce the population. That's what we call sample. Okay. Okay. There are two basic statistics in our statistic course: descriptive statistics and inferential statistics. Descriptive statistics mean it consists of method to organize and summarize our information. Okay, so we can organize what we have and summarize. Simply, we use to organize and summarize construction by using construct a graph, charts, tables. Okay, I think you have seen this, like bar charts, pie charts, simply a table. Those are the methods what we are using to organize our data and summarize our data. Okay. Okay. This descriptive statistics we can perform on top of population or sample. So we can use sample or population to use this descriptive statistics. Okay. Then inferential. Inferential statistic is the most prominent case what we are using, because this inferential statistics we perform only for the sample. Okay, we do not use this inferential statistics to do something on population. Okay, this is specifically based on sample. So this is same thing like consists of methods for drawing and measuring the reliability of conclusion about population by using a sample. Okay, please be noted that inferential statistics based on sample. Okay, but descriptive statistic you can use for sample or population, it doesn't matter. Okay. Okay. I have mentioned in the blue color text here. It is what I already told you. The information is obtained from a sample of a population, and we draw a conclusion about population that based on our sample, we call that study is inferential statistics. Okay. Okay, simply a parameter mean a numerical summary of population, and statistics. This statistics is not our statistic. Okay, statistic word. That statistic word we can use so many places with different ideas. But here, statistic mean some kind of estimate. Okay, numerical summary of sample which we have taken from the population. Okay. Okay, let's check this exercise. This is on your I think, yeah, this is the example one which I added into your chapter 1 note. So I have already I think, if I'm correct, I added 1 or 2 questions like this into your mid exam to understand, to check whether you have understand that the idea behind the population and sample. Okay, this question directly based on population and sample. Okay, there is no calculation, just an idea. Okay, this example says that an employee at the local ice cream parlor asked 3 customers if they like chocolate ice cream, then identify the sample and population. Okay. Okay, first of all, I think easiest one is to identify the population. Okay, so what is the population here? An employee at the local ice cream parlor asked 3 customers if they like chocolate ice cream or not. 3 customers. So directly we can say the population is what? All customers. Okay, population is all customers. Okay, then what is the sample? Ask 3 customers. Okay, 3 customers. Sorry. Okay, sorry. Here, population is all customers. Ask 3 customers if they like chocolate ice cream or not. What he's testing here? I'm sorry, I just missed that one. What he's testing here, whether his customers would like to chocolate ice cream or not. Okay, but what is the sample here? Sample is customers. How many? 3 customers. Okay, because he has selected only 3 customers among all customers. Okay, so all customers is the big picture, which means population, and 3 customers are the sample which he has taken from the population. Okay. Okay, sorry for that. As I mentioned, in this observational study, it directly based on what we have. Observation study is something like we observing data that already exists. Okay, something like that. So if we have a data set, we observe that, we analyze that, then we call that observational study. There is no new thing, just we do our experiment or we do our research on top of that what we have. Okay, so design of experiment or design experiments mean we are doing an experiment. Okay, it's a new thing, we are doing an experiment. Researchers impose treatment and controls and then observe characteristic and then take measures. Okay, it's like something doctors are doing. Okay, they observe something, they take measures, something like that, then finally draw a conclusion. Okay, we use this both observational experiment, observational study and design of experiment in statistics. But the difference between these two is the observational study based on what we already have, but design of experiment based on observe some characteristic and then take the measurements. Okay. Sorry. Okay, let's go through these exercises so that you can understand what is the difference between observational study and design of experiment. Here, an educational researcher uses school records to determine that one school in one school district, 84% of children, okay, 84% of children living in two-parent homes graduate high school, while 75% of children living in single-parent homes. Okay, so this researcher has drawn a conclusion based on what? Based on the data or based on the information that he has. See, he has 84% children living in two-parent home, and 75% of children living in single-parent home. Okay, he knows that. He knows about these two, who lives in two-parent home and who lives in single-parent home. So he drew a conclusion based on those two which he has. So this kind of study we call observational study. Clear? The next one, a clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out the find out if the drug has an effect on patient's illness. Okay, most of the time, clinical trials like checking the patients and giving a placebo, something like that, goes into the design of experiment. Okay, design experiments. So same here, clinical gives a drug of group 10 patients and placebo to another group. What they are trying to do here? They are trying to do an experiment here. Okay, there is no existing results. They are doing an experiment. So we call this design experiment. Okay. Okay. Now you know what is the population, what's the sample. But the problem is, how do we select a sample from the population? Can we take what we need? This one, that one? No, we cannot do that like that. Okay, we should have a proper method or proper technique to select a sample from our population. Okay, it should be a precise one, almost all. Okay, so there is a simple sampling technique we call simple random sampling. There are so many sampling techniques in statistics, but in this course you need to know it's enough if you can understand the simple random sampling. Okay, it is the easiest one. We've taken a sample by using random numbers. Okay, by without selecting this one directly according to our own choice, we just perform some kind of randomized procedure to select our sample. Okay, so that the sample of the given size is equally likely to be the one obtained. Okay, everyone in the population has an equal chance to be selected into the sample. Okay, we are not taking everyone, but they have a chance to select equally. Okay, we have population. So simple random sampling we can perform under with replacement, without replacement. What is with replacement? With replacement means we can use members in the population again and again, many times, more than once. Okay, without replacement mean we use the members or objects in the population only once. Okay, let's check this example. In this example, they mentioned that the finalists in an essay competition are Lisa, called L, Melina, called M, Ben, called B, and Eric, called E. Okay, these are the 4 finalists. I'll use these capital letters. First thing, list all the possible samples of size 2 that can be obtained from this population of 4 finalists. So what are the all possible samples, or simply we can call all possible occurrences that we can create couple. We can create a couple, which means a size 2. Here they have mentioned a specific thing here: without replacement and order doesn't matter. Okay, we need to select 2 of them, but no replacement and order doesn't matter. What is this order doesn't matter? For an example, if I select Lisa and Melina, which means L, M together, so it doesn't matter, you select ML. Okay, LN equals ML, same thing. Okay, that's what they have mentioned, order doesn't matter. ML or LM, they are same. Okay, so order doesn't matter, then how we select 2 of them from this among these 4? First, if you have this kind of question, actually you will be having a question not like this, but very similar question in your exam as well. How we pair them, or how we list the all possible outcomes using something like this. First, catch the first one. Okay, first hold the first one and make pairs with first one. Okay, like first one is L here, so I'm going to cache L, then make pairs with L. L M, first pair would be L M. Next one is L B. Okay, next one is L E. Okay, so have we done with all else? Yes, with this Lisa we have coupled all these people here. Next, go to the next one, hold this guy, hold M, and create these pairs MB and ME. See here, MB and ME. Okay, next hold this, the next one, which means B and E. See, BE, because we have only one to couple with this one, so BE. Okay, then E. Do we have anything else here? No, it is the last one, so there is no people after E, so there is no pair here. Okay, you don't have to go back, or you don't have to check back with ML or BM. No, because they are similar. Since we are considering order doesn't matter. Okay, altogether we will be having 6 of pairs, so we will be having 6 possible outcomes or 6 samples. Okay, if a sample if a simple random sampling method used, okay, that's the sampling technique what we are using, is used to obtain a sample of 2 of the finalists. What are the chances of selecting Lisa and Ben? Okay, what is the chance, or simply we call this what we call this probability. Okay, I'll teach you that later. What is the chance of selecting Lisa and Ben? So where is Lisa and Ben? See here, the same list I have mentioned here, Lisa and Ben. Okay, are there any Lisa and Bens? No, only one pair here. Okay, among how many? Among 3, 4, 5, 6, among 6 pairs. Okay, so altogether you have 6 pairs. How many pairs that you have Lisa and Ben? It's just 1. So 1 over total outcome 6. 1 over 6 is the chance that Lisa and Ben can be selected. Okay. Yes, total 6 possible outcomes. So the probability is, or probability or the chance of being selected, okay, is 1/6, 1 over 6. Okay. Okay, this is the end of this chapter 1. If I'm correct, then you will be having one, maybe 2-3 questions based on this part to find the chance of selecting this and that. Okay, let's go to, if you have any question while I'm talking here, just turn on your microphone and ask the question at that time. Okay, don't please don't wait until the last minute. Okay, then I'm going to do the chapter 2 review. I hope that you can see this. Yes. Okay. Chapter 2. This is based on organizing data. In this section, in this chapter 2, there are so many definitions. Okay, since you can refer your notes in the exam, you don't have to memorize all the things, but try to understand what is these terms. Okay, so it will help you to do your exam real quick. Okay, so okay, I'm not going to explain one by one, you can go through this, but I'll explain you what are the major things we are using in statistics. Variable, yes, we use variables everywhere. Okay, a characteristic that varies from one person to another or one thing to another. Okay, it's a characteristic, something we need to varies from, we need to vary from one to another. Call it, there are two variable, there are not two, actually there are so many variable types, but specifically we can define a few variable types like qualitative, quantitative variables. Okay, qualitative mean non-numerical values, qualitative. Quantitative mean numerical values. Okay, so quantitative variable mean a non-numerical valued variable, and quantitative variable mean numerically valued variable. Okay, so discrete and continuous. What is discrete here? Oh, sorry. Discrete mean remember that discrete and continuous are quantitative variables. Okay, numerical variable, numerical stuff, discrete and continuous. So what's discrete variable? Okay, let's say what is discrete. Discrete mean we can count it. Okay, we can count all possible values, finite numbers. There are finite numbers, we can count them, 1 2 3 4 5 6 like this. Okay, quantitative variable with only a finite number of possible values is a discrete variable. Okay, we call that discrete variable with combination of these two words, discrete variables, which mean a quantitative variable whose possible values can be listed. Possible values can be listed because it is discrete. It's a variable, it is quantitative variable because it is a discrete variable. Okay, same here, continuous variable. Continuous mean that there are finite, not finite, there are infinite numbers, we cannot count them, like 1.1 1.2 1.111 1.111111, something like that. We cannot mention all the possible outcomes there. Okay, continuous variable mean a quantitative variable whose possible values we can put inside the interval, put inside an interval. Okay, but we cannot say these are the values. Okay, it's just a basic idea which came from mathematics directly. So variables, variable, there are two types, qualitative and quantitative. See, qualitative, those are non-numerical, which means sex, eye colors, I mean gender, eye color, your blood type, something like that. They are not numbers, they are like just letters or something like that. But quantitative mean numbers, weight, height, number of siblings. Okay, so quantitative variable you can divide into two pieces, discrete and continuous. Okay, discrete, you can use the same example. Discrete, number of siblings. Number of siblings can be 0, 1, 2, 3. Okay, there are no values in between 1 and 2, right? There are no 1.5 siblings, something like that. Okay, so continuous is like weight, height. Weight can be 50 pound, 50 pound, 0.5, 0.6, something like that. Okay, we cannot say exact value. Okay, so if we consider data, again we have the previous four stuff: qualitative data, quantitative data, discrete data, continuous data. Okay, only thing is you should know what is data. Data, value of a variable. Okay, data means values of a variable. You have a variable, then you have values of that variable. So we call it data. Okay. So qualitative data is a value of a qualitative variable. Okay. Quantitative data, values of a quantitative variable. Okay. Okay. Same as the variable, you can divide data into two pieces, qualitative and quantitative. Again, quantitative, since it is numerical, you can define it like discrete data, continuous data. Okay. So if you get a data set, okay, you can find it in the internet or everywhere we have data sets. They are either qualitative data set or quantitative data set, or they can be combination of those two. Okay. Okay. Qualitative, these are the examples for qualitative data, like as I mentioned, blood type, marital states. Discrete, number of siblings, number of pets. Continuous, weight. Okay. Organizing qualitative data. Now you know what is qualitative data and quantitative data. We are going to organize them because that's our goal, to organize qualitative or quantitative data. Quantitative data, sorry, this is qualitative, right? Yeah, qualitative data. Number of times particular distinct value occurs is called frequency. Number of occurrence, normally we call frequency. Okay, number of occurrence we call frequency. So this frequency we can mention as a frequency distribution. Distribution of that frequencies we call frequency distribution of that qualitative data set. Okay. Okay. How we draw or how we define this frequency distribution of qualitative data? List all the distinct values like a column of a table. Then count how many occurrences are there for each distinct value. Okay, how many occurrences are there for each distinct values. Then you have your frequency distribution. So let's check this example. Democratic, Republican, others. There are three categories. So you can count how many Democratic are there, how many Republican are there, how many others are there. Okay, you can just count them. So I have mentioned here in this table. So party is Democratic. How many? 13. Republican, there are 18 occurrences in this previous table, this table. Okay, another 9. So altogether there are 40. Yeah, there are 40. Okay, so these are the frequencies: 13, 18, 9. Those are the frequencies, and 40 is the total frequency, which means the total number, total occurrences. Okay. Okay. Now we are going to talking about relative frequency distribution. First we talked about frequency distribution. Now we are going to talk about relative frequency. It's easy because only thing you have to do is divide your frequency by total number of observations. Right here, relative frequency equal frequency divided by total number of observations, which means simply, let's say Democratic, what is the relative frequency for Democratic? For Democratic, it is frequency is 13, so you can divide 13 by 40 because 40 is the total number of occurrences. For the Republican, what is the relative frequency? 18 divided by 40. Okay, something like that. Frequency divided by total number of observations. That's what we call relative frequency. Democratic, 13 divided by 40. See, it is 0.325. Okay, so later you will see that this relative frequency mean same as the probability. Okay, same as the probability. Relative frequency value equals to the probability value. Okay, there are a few techniques. Previously I mentioned that we use like graphs, charts. Okay, this is a pie chart. Is a disk divided into pieces. Okay, wedge-shaped pieces, and we mention those frequencies in our data set. Okay, since we are talking about qualitative data, see this pie chart based on qualitative data. Okay, before you do anything, you should do or you should find these relative frequencies first. Okay, first find the relative frequencies based on your qualitative data, then divide your disk into wedge-shaped pieces proportional to the relative frequencies. Okay, then finally label them. Okay, don't forget to label them, otherwise nobody knows what is this, what is that. Okay, see, based on their proportion you can divide this disk. Okay, normally we mention this portions of this disk by using percentage. You can get the percentage simply by multiply your relative frequency value by 100. Okay, relative frequency multiplied by 100 gives you the percentage value. Okay, bar chart, it is easiest way to display the distinct values. Okay, distinct values, just bars. That chart based on bars. Height of the bar gives you the frequency of that particular bar. Okay, height represent the frequency. Clear? Same as the previous one, you have to first draw the relative frequency distribution, or you have to figure it out what are the relative frequencies. Then x-axis and y-axis, horizontal axis and vertical axis. See, something like this. Vertical axis always mention the relative frequency or frequency. Okay, horizontal axis mention the items, or in this case party, Democratic, Republican, other. So this bar belongs to Democratic, second bar belongs to Republican, third bar belongs to other. So height of this bar represent the relative frequency. For the Democratic, I remember it is like 32 point, no, 0.325, something like that. Okay, so this height 0.325. Okay, okay, organizing quantitative data. Now we are going to talk about quantitative data. Check the time. We have enough time. So for the quantitative data, we need to group them before we interpret them, or before we show them. We have to group them because those are numerical. Okay, quantitative. There are numerical values. So there are three grouping techniques: single value grouping, limit grouping, and cut point grouping. This single value grouping, which means if we have discrete data for small discrete numbers, small distinct numbers, discrete data that we have small number of distinct values or unique values. For an example, we have discrete values like 0, 1, 3, 5, 6. Okay, they have different frequencies, so that we can use this simple value grouping technique because we have only few distinct or unique values. Okay, limit grouping we use if we have many distinct values or many values, too many distinct values, we use limit grouping. Okay, that's the difference between single value grouping and limit grouping. Single value grouping, single value we use only for few or small number of distinct values. Limit grouping, we are using discrete values which are too many distinct values. There are too many distinct values. So cut point grouping, it is specifically for continuous data. Okay, cut point grouping we are using to represent the continuous data. Okay, first two grouping technique we use for discrete cases. Okay, let's take this one, grouping into classes. There are some guidelines which you should keep in your mind. It's not just it's not rules, but they are like guidelines. You should know that number of classes, you always try to keep the number of classes like small number of classes. Don't go too many classes. Don't divide your data set into too many classes. Okay, for rule of thumb, we say that like now there are classes like between 5 to 20. 20 is like, it depends on, but don't go that much. In your case you don't need that much, but always try to keep your classes in between 5 and 20. Okay, otherwise it is too much, it is hard to identify, hard to read, something like that. Okay, so each observation, remember that in your data set, each observation must belong to one class only. Okay, no observation can go into two classes. Okay, always try to keep the width or gap between the classes equal. Okay, if I use the same example, I guess. Okay, you have a data set here. See, 0 1 3 0 2 2 1 1 0 1 4 2. There are so many repetitions here. Okay, among this data you have to figure it out, what are the distinct values. That's the first thing you have to do. Okay, what are the distinct values? 0 1 2 3 4. See, 0 1 2 3 4. Then you can calculate frequencies. How many zeros are there? 1 2 3. There are, okay, let me there are 3 zeros. How many ones? 1 2, okay, 1, how many ones? 1 2 3 4. There are 4 ones. Okay, how many twos? 1 2 3, 3. Okay, something like that. There are 12 altogether. There are 12 numbers here. Okay, so total possible numbers is 12. So how you get the relative frequency? For 0 you have to divide 3 by 12. Here 4 divided by 12. That's how you get the relative frequency. You can fill these gaps. Clear? Okay, let me go back. Okay, when you are using these groups, there are a few terms we call lower bound and upper bound. We call that lower class limit and upper class limit. Sorry, a lower class limit means the smallest value in your class. Upper class limit means the highest value in your class. Class width means the difference between upper class limit and lower class limit. Class mark means the average value of your class. Simply upper class limit divide upper class limit minus lower class limit divided by 2, something like that. Okay, average. Okay, you have a table here. There are like I don't know how many, I think 40. There are 40 data here, but you can see there are you can see they are distinct values. Okay, they are sorry, they are discrete values. They are discrete values, as well as you can find discrete values. Okay, you can find discrete values here. discrete values, and you can find distinct values, unique values here. But the problem is how many unique values here. There are many unique values. Okay, so simply you cannot interpret this, or you cannot show this by using single value grouping. You have to go limit grouping. Remember the definition of the limit grouping? Okay, so you have to introduce sorry uh, sorry you have to introduce sorry for that. You have to introduce groups. Okay, you can start your group from the lowest value, and you can end whatever groups in your highest value. Okay, so what is the lowest value? I think you can find it. I have mentioned here. So lowest value is 30. So first you have to figure it out, what is the lowest value and what is the highest value. Okay, then sorry for that. First try to identify what is the lowest value and the highest value. Then my recommendation is try to divide them, like by using 5, 10, something like that, so that you can uh, get a rough idea how many classes you should include in your table. There is no specific rule. This is the number of classes you have to input here. No, try to minimize them, like one class, like 5, width is 5 or 10, something like that. Okay, it depends on the data set, so I cannot tell what is the width or what is the gap between classes. So you have to pick it by yourself. Okay, so in this case they have divided their classes like 30 to 39, 40 to 49, 50 to 59, something like that. Okay, so 30 to 39, all values including 30 and 39 inside this class. Okay, including 30 and 39. All values including 40 and 49 goes to this second class. Okay, likewise you can calculate the frequencies, then you can get the total number of data here is 40. So then you can find the relative frequencies by simply divide this frequency by 40. 3 divided by 40, this value. 1 divided by 40, this value, something like that. Okay, so I'm telling you once again, relative frequency equals to the probability. Okay, remember that relative frequency value, those values always in between 0 and 1. They cannot be greater than 1. Okay, if you get a relative frequency value like 1.2, then it's wrong, you should check it. Okay, always relative frequency values in between 0 and 1, including 1 and 0, that's fine, but in between those two values. Okay, sorry, last one, cut point grouping. Cut point grouping, same as the limit grouping, you have lower class value, upper class value, class with midpoint. Okay, why we use this cut point grouping? If we have continuous data set. Okay, so you have a data set for 15 college students, those are weights in pounds. See, those are continuous values. 151.3, something like that. Okay. So first in here they have mentioned use the class width 10, and the first cut point start from 40, 140, sorry, 140. Okay. Okay. What is the highest value or simply heaviest here? 191.1. This one, 191.1. Lowest one is 145.6. So for if you start your first class from 140 to 150, what will happen? 140 and 150. So first class is 140 and 150, which means width is 10. Gap between those two is 10. Okay. The next class you can start from 150 to 160. 150 to 160. Again, here as well, or one observation belongs to one class only. Okay. Since they are continuous, you don't have a problem here. What will happen to the 150.1, no 100? What will happen to the 149.9999? Don't worry about that. Okay. If whatever less than 150 goes to the 140 150 gap, that class. Okay. Okay. Class width, you can find the midpoint. Okay, I think that's, I need to talk about this point. Okay, see this one, 140 to 150. Weight whatever within this interval goes to this first row or first class, 40 to 50. Under 50, see, you don't need to mention this one under 50. You can just use the hyphen and mention 40, 50, 140, 150. That's fine, because everyone knows that if we are using cut point grouping, which means this first class belongs to whatever greater than 140 and less than 150. So 149.999 goes to this first class. Okay. 150.1 goes to second class. 150 to 160. Okay. Histogram. Histogram. Normally we use this histogram to show the or interpret our data set. This histogram very similar to bar chart, but please don't mix them up. Bar chart and histogram, there are many differences. Okay, in the bar chart, you saw that there are gaps in between each bars. Okay, but in histogram there are no gaps in between bars. Okay, they are very similar, but those are the differences. There are a few differences as well, but major difference is there is no gaps in between bars. Same as bar chart, the height of the bar represent the relative frequency or frequency. You can use it for single value grouping, limit value grouping, cut point grouping, doesn't matter. Okay, so histogram is very popular graph that you can use. First you have to obtain the frequency, then draw the horizontal and vertical axis, and then define your classes. Okay, see for this one I think single value grouping, yes. See, you have few distinct values, discrete distinct values, few. So you can calculate the frequencies and relative frequencies. Then you can draw your histogram based on this distinct values. First bar belongs to 0, second bar belongs to 1, third bar belongs to 2, something like that. Okay. Single value grouping. Okay, what is this? Frequency histogram, relative frequency. Okay, they are very similar, frequency histogram and relative frequency histogram. Okay, their shape is very same. So first bar belongs to 0, second bar belongs to 1. There is no group here. Okay, just single value grouping, single values, only single values are here in the x-axis. Okay, if you draw the relative frequency, same as the frequency, okay, you have to divide each frequency values by total number of outcomes, which means in this case 50. You have to divide each frequency value by 50. Then you can draw this relative frequency histogram. See, there are no gaps between bars. Okay, this histogram also you can use for limit grouping. See, there are groups 30 39, 40 49, 50 59. So this each group has a 1 bar. Okay, see, 30 to 40 belongs to this bar, 40 to 50 belongs to this bar, the second bar, something like that. Doesn't matter frequency or relative frequency, they are very similar, so don't worry about that. If in the question they have mentioned like you have to draw the relative frequency, then don't draw the frequency, draw the relative frequency. Okay, they are very similar, yes, but their values are different. Okay, see, frequency values, this y-axis or vertical axis and this vertical axis, values are different. Okay, so you can do the same thing for cut point grouping as well. So, okay, there is another specific plot type we call dot plot. Okay, in this dot plot we will be having only x-axis or horizontal axis only. On the horizontal axis we have mentioned our values, and on top of that horizontal top of that values we draw dots based on the frequencies. Okay, those number of dots call the frequencies. Okay, I think see, in this data set there are 16 number of values. See, x-axis, this horizontal axis, we mentioned prices, unique prices, 109. They have divide this in from now 190 to 230, 190, 200, 210, 220, 230. Okay, now you can read this value and put a dot above those values. 210, whereas 210, 200 is here. Okay, 201, sorry, 200 is here, 210, see here, you can put a dot here. Second value 219, 219 just before the 220 here. There are so many 219, there are 3 219s in this data set, so that's why you have 3. If you have a repeat number, then put a dot above the previous dot. Okay, so this goes up, this dots goes up. Clear? When you count the number of dots, let's say 210, there are 2 dots, which mean there are 2 occurrences belongs to 210 in this data set. Okay, stem leaf diagram, this is, I think you already know this one, stem and leaf. We call it stem plot. Simply I call this stem plot. You have stem and plots. Okay, I'm not going to explain the steps, but I'll show you how to do this. First you have to divide your values, each value, into 2 pieces. Okay, like let's say right hand side and left hand side. So right hand side of that particular value should be 1 digit. Okay, 1 digit, remember that. So in this stem leaf plot you have left hand side, this means blue color values, right hand side, this means these values. Okay, right hand side of the stem plot we call leaves, left hand side of the stem plot we call stems. So leaves can be 1 digits. Okay, if you, for an example, if you have 70, you have to split this into 7 and 0. Okay, so 0 goes to leaves, 7 goes to stems. Clear? So this left hand side you have to order them into ascending order, and this each set, each column, each row has to be ascending order. Okay. First, you can put the values, read this table and put the values to the system leaves, and then you can order them like this A and B. Okay, this A is the unordered one, B is the ascending ordered stem plot. Clear? So always how we read this is going to be 36 values in the left hand side with values in the right hand side. 36, 38, which means 36, 38, 39. There are only 3 values, belongs to 30s. Okay, start from 40, 47, there are only 1 value, something like that. Okay, remember that you have to keep this in ascending order in stem plot. It is a must. Okay. Okay, if you have 3 digits, which means 200, 205, something like that, if you have 3 digits, then what you have to do? Always 1 digits for, always 1 digits for leaves. Okay, don't forget that. Always 1 digits belongs to leaves. Then you can perform like this, like A. Okay, 1999, 199, 200, 202, 203, something like that. Okay, or you can divide this one group into 2 groups like this, like values just below below 195 goes to this part, values above 90, values above 195 but below 200 goes to this one, something like that. Okay, it doesn't matter, you can divide into 2 pieces, below and above, doesn't matter. Okay. Okay, there is only a small thing here, distribution shapes. So we have few slides to finish this chapter 2. Distribution shapes, that's something very important stuff in your exam. Okay, distribution shape, it represents the shape of the data set, simply shape of the data set. Okay, see, when you draw a histogram, then you can connect the midpoints of those bars. Simply you can draw a curve, a smooth curve. We call it a smooth curve because there is no lag in this curve. Smooth curve, then you can see, okay, there is a shape, right? It's like a bell shape. So we call this distribution. Okay, so this shape can be shift into one side like this. See, we have peak in our left hand side, but this one, see, peak in the middle of this shape, right? It is perfectly bell shaped. We call that perfectly bell shaped because it is symmetric. See, it is perfect, but this case is not perfect. Why? Because it's shift to one side. Here peak goes to left hand side, part B this goes to right hand side, P goes to right hand side. So we call them right skew based on their tail side. We call this is a peak, and we call this part is tail. Okay, this is like a tail. This right hand side of the graph A we call tail. So tail side, we use the tail side to denote the, or to represent the shape. So we have tail in the right hand side, so this is right skewed. We have in graph B, we have tail in the left hand side, we call left skewed. Okay, so there is a reverse J-shaped distribution. Actually, we don't need this one in our course. Reverse J-shape, we don't have this kind of data set. Okay, so just skip that one. See, using relative frequency or frequency distribution, you can draw this kind of curve and see how this data are distributed. Okay, like this. See, so many data in these parts, so P goes to this side and small number of data in this part, so it's like a tail. Okay, if you see a question like this mean you have some kind of data set, and question asks to identify the shape of this data set. You can simply draw a histogram and identify the shape, or just draw a stem plot diagram or stem plot table and check the pattern. Okay, just check the pattern, no need to go through the values, just check the pattern. Draw a relative frequency histogram and check the pattern. See, in the first graph you can see first 4 bars, they have like some considerable frequencies, and the rest of them they are like decreasing. Okay, so first few increasing, then decreasing, which means this pattern in part B, in graph B. So this is a skewed graph. Which side? Name them using its tail side. So this is bump goes to left side, tail goes to right side. So this is called right skewed data set. Okay, clear? Okay. There are 2 things you should know: population and sample data. Actually, I think you need to know this as well. You have a question from this: population data, sample data. So you know what is population and sample. So data, what we have, population data, the values of a variable for entire population. Okay, sample data, value for a sample of the population. So distribution of a population data we call population distribution or distribution of the variable. Okay, distribution of sample data we call sample distribution. What is distribution? Simply like this. How this data, if we draw this histogram, how this data goes, how this data move, like increasing first few, then decreasing, something like that. Okay, shape of the distribution. Okay, I think that's for chapter 2. Okay, yeah. Do you guys have any questions? Because since I have few minutes, I'll try to go through the review. Do you guys have any questions? Let me check the chat. Okay, where is that one? Okay, do you guys have any questions? Please. No questions. Okay. Okay. I'm going to move to your review. Okay. Share again. Okay. This is a review which I sent you last week, and also I have added this into your Blackboard. Okay. It's really hard to take a PDF from my StatLab. Okay. It comes with answers. So as I mentioned, see this. Okay, I'm sorry. This question, first question based on population and sample. I told you last time my exam or my mid exams very similar to review. Okay, so there are 30 questions, 25 questions plus 5 bonus. Okay, so each question like 4 points. Each question has 4 points, so you will be having 4 times 5, 20 bonus points. Okay, okay. First question based on population and sample stuff. Okay. Oh, same. The second one is the same example. Okay. Second one is the same example which I discussed. Okay. I'll go to the first one. Magazine publisher mails a survey to every subscriber asking about the timeline. The publisher find that only 6% of the subscribers respond. 6% from the subscribers. Sorry. So what is the population here? All the subscribers, right? To every subscribers. So all the subscribers are the population. But what is this 6%? 6% mean a sample from the population. Okay, so it is the sample. Okay, third one. See, I told you this kind of question can be there. Okay, for the review, I have mentioned two questions. First one, you have to find the all possible outcomes. Okay, there are 20. I have mentioned them. Okay, so you don't have to worry about that. There should be 20 possible outcomes. Okay, so once you have figured it out, there should be 20. Okay, so you have to count them at the end. Finalist in essay competition. Okay, same question, but there are how many? 1, 2, 3, 4, 5, 6. There are 6 finalists. Okay, list 20 possible answers without replacement. Okay, I have mentioned them without replacement. The size of 3. This time you have to find a size of 3 possible outcomes. Same as you can start from first one, L. Then try to combine others to L. LMB, then what? LMD, LME, LMJ. Okay. Then catch L and B. LB with D. LBE, LBJ. Okay. I think I have clearly mentioned that in your in this handwritten or handwritten answers. Okay, please check this handwritten answers. Okay, because I have explained them as much as I can in this handwritten notes. So there are 6. See, go through these arrows. First LMB, then LMD, LM next one E, LMJ. Okay, something like that. So you can find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes from this first picture. And next one, which means after you finish your job with L, you can just forget about L. Okay, no need to consider L for your rest of calculations. Now you can start from M, MBD, MBE, something like that. So likewise, you can figure it out, 20 possible outcomes. Okay. Next, you have to find the probability or selecting chance. Okay. So altogether, how many? 20. Okay. Altogether, 20. So what they ask? The final. Okay. In this case, it's a little bit different. It's not same as this question number 3. It's a different question. Okay. In this using this 4 1, 2, 3, 4, 5, 6 among these 6 finalists, you have to find the what you have to find the chance of having chance of selecting Lisa and Denny. Only 2 sample sizes. Previous one 3 sample, but here it is 2. So you have to pair them 2 by 2 like couples. Okay, couple them LM, LB, LD, something like this. This population of 6 finalists are okay. It's given. Okay, so you don't need to worry about that. You have LM, LB, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Altogether you have 15. Okay. So what they ask, Lisa and Danny, how many LD here? I can see 1. Yeah, I can see only 1. So frequency is 1, which belongs to Lisa and Danny, divide by number of total outcomes. Total outcomes, there 15. 1, 5. So 1 over 15, third one. Clear? So it's not a very complicated calculation. Okay. So in any case, you cannot see this all possible outcomes. Please try to write them. Okay, and get the value. This is easy. Just look at this and write the answer. No need to worry about the values. Okay. First, read the question carefully before you go into the calculations. Okay. Here you don't have to do any calculation. What kind of data provided by the information in the first column? Okay, first column, media. What are they? CD, singles, MP3, DVD. So they are what? Qualitative. There are no numerical values, which mean qualitative. If they have numerical values, they are quantitative. Okay. You simply you can refer to your notes while you are doing the exam. Okay. You can use a calculator, no problem. Actually, I recommend you to use the calculator. Okay, otherwise it's hard to do these calculations. This one, find the relative frequency column for Arizona. Arizona, last one. Relative frequency. So what is the total frequency here? So to find the total number, you have to add these frequencies: 20 plus 96 plus 19 up to 8. So I don't know what is the let me check this 6, number 6. Okay, total it is 200. Okay, for the Arizona it is just 8. Frequency is 8. So relative frequency 8 divided by 200. 8 divided by 200, 0.04. 0.04. Okay, so simply you can add these frequencies to get the total frequency by using the calculator. Next one goes to following. What type of grouping? Number of pets per family. Okay, number of pets per family. It is continuous or discrete? It is discrete, right? Number of pets, 0, 1, 2, 3, 4. Now the problem is how we represent them. We have 3 ways to categorize them: single value grouping, limit grouping, or cut point grouping. These values are discrete, right? 0, 1, 2, 3, 4. So simply you can reject this cut point grouping, but you have single value grouping and limit grouping. So among them, which one is the related one? Number of pets per family. It is there are distinct values, right? 0, 1, 2, 3, 4, 5. There are few values, right? There are no huge values. 20, 45, 60. There is no something like that. So simply this belongs to single value grouping. This kind of question can be tricky, but just try to identify number of pets, number of siblings, number of friends, something like that. Those are discrete and single value grouping stuff. Okay, because we can count them. Okay, relative frequencies. Okay, using this data set, you have to find which frequency distribution is the correct one. Okay, all four seems to be like similar. For these cases, you have to find like, you don't need to do more calculations. First, try to catch first two or first three frequencies belongs this. So here is 11, 12, 13. So count how many 11s are there, how many 12s are there, how many 13s are there. Okay, so I can see that these two are different, so definitely you can eliminate the last two, but first two, they are similar. Okay, since they are similar, you can simply check what are the different values. Okay, I can see 14 is different, which means fourth one. For the first one, it has frequency 5. For the B, second table, it has the frequency 6. So you can simply check how many 14s are there. It should be 5 frequency, number of 5 observations. Okay, so answer is A. You don't have to go through all the values. Okay, just pick few values and select. Easiest way is to do this kind of question. Check all the answers first. Okay, check all these 4 tables and try to identify similar tables. See, so if you check these 4, you can see these first 2 are the similar tables. So simply you can just forget about this for a moment. Okay, I cannot say that's the perfect method. Okay, sometimes D can be the answer, so don't think like that. Just forget about last 2 for a moment and check these 2, so you can reduce the number of answers here, number of possibilities. Okay, so you have to select which one is the best among these 2. Clear? Then check the different numbers. Okay, this is also that kind of question. This is single value grouping. If it is single value grouping, okay, there is no groups, there is no classes like this. Okay, so number B or part B definitely is the wrong answer. Okay, see, this is single value grouping, so you have to pick your answer from A, C, D. Okay, okay, as I mentioned, there are no similar graphs unfortunately, but A, C, D, it is easy. You can check the first one. Do we have zeros? Yes, we have zeros. See, in our data set we have zeros, so 0 should be there. See, part C, there is no 0 in the number of novels, so eliminate that one. So answer gonna be A or D. Then calculate how many. 0, 7, both both of them have 7, but 1, if you consider the number of novels 1, they have different numbers, so you can check that value and pick the answer. Okay, that's the easiest way. So you don't need to go through all the values, just pick few values and try to figure out the answer, so that you can save some time, especially in the exams. Okay, don't worry, I have given time is like more than enough, so you can do your exam in free mind. Okay, since I did the dot plot last, finally I'll do this one and I stop my review for today. So this dot plot, this should be a dot plot, so it has only horizontal axis. All values should be mentioned on the x-axis or horizontal axis. Now what you have to do, try to pick the similar one. Check, see, these 3 very similar, A, B and D, but C, there's a value for 20, but all others, they don't have a value for 20. So you can check, do we have value 20? If yes, then definitely C is the answer. Okay, but let's check. We don't have 20 here, which means C is not the answer. The answer should be A, B, or D. Next, check what are the difference between these three. See, for 16, D, it doesn't, there is no value for the 16. So you can check 16. Do we have a value or not? No, we don't have 16 here, which means A and B are wrong. D is the correct one. Okay. So likewise, try to play with a few values and figure it out the best figure. Okay. Okay. So for today, I'm going to stop my review. If you have any question, please ask them or just email me. I'll continue this review and chapter 3 summary in next day. Okay, so if you have any question, this is time to ask. Okay, if you have any question, you can just email me, no problem, anytime. I'll try to reply them as soon as possible. And also I'm going to do the chapter 3 summary, not the chapter 3 summary next day, which means Thursday from 11 like 40 to 1 p.m. and also I'll try to go through the other questions in the review as well. Okay, so don't worry about the exam. It is very similar to review, very similar to the review. You can use your notes. You can, if you want, you can use this review as well. So use graphing calculator, whatever, no problem with that. Let me check the questions. Will this session be uploaded? Yes, I'll upload this session to the Blackboard as soon as I finish this meeting. Okay, so you can go through this again. Okay. Okay, then since you don't have any question, I'm going to stop this session. Then see you on next day. Okay, have a nice day, guys.